In this video, we'll look at core level interrupts used in the MMUART interrupt example project. As well as the PLIC interrupts available on PolarFire SoC, you can also raise a core level interrupt between MSS hearts. To demonstrate this, we'll use the MPFS MMUART interrupt example project from the PolarFire SoC bare metal library. This application runs on the E51 and waits for the user to enter values on the terminal before raising interrupts on the individual U54 hearts to take them out of wait for interrupt mode. Let's start a debug session using this project now. When the debug session starts up, we'll reach a breakpoint on the E51 main. All of the other U54 hearts have also reached their main function, but what's different is they'll all enter wait for interrupt mode once we start the program execution. And the U54s will loop here, executing the wait for interrupt instruction until they receive a soft interrupt in the MIP or machine interrupt pending register. Once this soft interrupt is detected, the heart will clear the interrupt and then enable all of its global interrupts and initialize itself and start printing hello messages over UART. So let's set a breakpoint on line 56 so we know when this heart has woken up. And we can do the same thing for the U54_2 and the U54_3. I don't have a UART connection for heart 4, but it'll still start up, so let's set a breakpoint there as well. Each heart will output messages over a different COM port. We've the E51 in the top right, the U54_1 here, the U54_2 here, and the U54_3 in the bottom right. Now that we've set up our breakpoints, let's go back to the E51.c file. There's not much point stepping through this project, so let's just run it and give it a try. Now the program is started up, the E51 has printed a hello message on the terminal with instructions. If I enter 0, I get debug messages. If I enter a value between 1 and 4, I raise an interrupt on a U54. And if I enter 5, I show the menu again. We've also reached a breakpoint on U54_1, but this heart is going to re-enter wait for interrupt mode here. So let's just resume the program. And you can see, even though we resumed the program, we haven't reached the breakpoint on line 56. If we return to the E51.c file, we can see that if we enter a value of 1 on UART, we raise a soft interrupt on heart 1. So let's give that a try now. Let's set a breakpoint on line 151, 156, 161, and 166. Now, if we enter a value of 1 on the terminal, we can see that we get a message printed out, and we reach the breakpoint on line 151. And if I resume the program, we'll reach the breakpoint that we set in the U54_1.c file. So now we can see that the heart has exited the wait for interrupt loop. So now, if we remove this breakpoint and resume the program, we'll get hello messages from U54_1 printed out on the terminal. All of the other U54 hearts are still in wait for interrupt mode, and we can check this by halting the program execution and then selecting the thread for a different U54 heart. So we can see U54.2 is still in the WFI loop. Let's resume the application again, and this time enter a value of 2 on COM0. This will raise an interrupt on U54_2, and we can see that here when we reach the breakpoint on line 156 of E51.c. And now we can see that U54_2 has come out of wait for interrupt mode, and if we resume the program, its hello messages are going to print out on UART 2. And if we raise an interrupt on heart number 3 and resume the program again, so now we can see that U54_3 has come out of wait for interrupt mode, and soft console has changed into the thread for this heart for us. In this example, the E51 was raising software interrupts on the U54 hearts. It achieved this using the raise soft interrupt function. It takes one argument, which is the heart ID of the heart you would like to raise an interrupt on. And in the case of the U54s, when they received a soft interrupt, there is also a clear soft interrupt function, which will clear any pending soft interrupts for the heart executing the instruction.